So as you're doing stoichiometry problems, an error that I'm coming across several times, especially on the review quizzes, and I'm sure we'll see it next week or 2 weeks on the homework, is that if you have a certain number of atoms, what can you do with that? Well, you can actually do a lot with that, and calculating the number of atoms is super important, especially in medicine, because it's the atoms, if we have elements, molecules if we have covalent compounds, or formula units if we have ionic compounds that actually go to our cells. And so anytime you have a problem in chemistry, always take a look at what you have to start with. What's given is where you want to start. And so if I have this number of atoms, the first thing I'm going to want to do is write that down. And you can put that over 1, or you can just leave it the way that it is. So I've got it should be 1.85 times 10 to the 24th atoms. I do have a typo there, which I did not pick up on. And then we're going to use the known quantities that we have. One of the known quantities we have is Avogadro's number, which is the number of particles in a mole. And moles, if you can get to moles of chemicals, then you can pretty much do anything with them, because moles are how we measure chemicals. And so I'm going to take that relationship, 1 mole equals 6.02 times 10 to the 23rd atoms, and I'm going to write that as a fraction style ratio or a conversion factor so that I can diagonally drop out my atoms. And there you can see those atoms are going to diagonally drop. And so now I'm going to have moles of magnesium. Well, this is asking for grams. So we always got to be looking at the problem. What am I asked for? Well, I know another relationship or known quantity that relates moles and grams, and that's the mass from the periodic table. And for magnesium, that is 24.301 grams of magnesium is 1 mole. Now, each of these are conversion style ratios or fractions, because they both equal 1. And so our atoms are going to cancel. Our moles are going to cancel or diagonally drop. And when I go straight across the top and multiply 1.85 times 10 to the 24th, and that's a tricky thing to type into your calculator. So if you're using the Deltec recommended calculator, the TI-30, again, the way you type this into your calculator is 1.85. Then in the upper left-hand corner, hit the second function and then the EE button, 24. So again, you would type that in like this, 1.85, second function, EE, 24, times the formula or molar mass, 24.301. Then divide that by Avogadro's number. That's 6.02 times 10 to the 23rd. Once again, the way you type that into your calculator, 6.02, second function, EE. That EE button is right above. It's one button above the 7, the x to the minus 1, and 23. Now, it's not going to look right. And when you type all of that in, I got 74.679. And I had to round that to 3 significant figures. So I've made it 75.0. I could have probably left it as 74.7, but I wanted it to be 75.0 for our next item here. And that is how you figure out, if you're given number of atoms, this is how you can figure out moles, you can figure out mass. Or if you have the mass, you could do this backwards to get to atoms. And why would we want to do that? Well, one more little stoichiometry problem for you. So if we have magnesium metal and we heated it with nitrogen gas, and the product, and we got the product would be magnesium nitride. So we could write the equation for that. Remember that magnesium is diatomic, so it can never be alone. And then we would use our crisscross rule to get the formula for magnesium nitride, Mg3N2. And if we had 75 grams of magnesium and 45 grams of nitrogen, how much of this product can we make? Which ingredient, which reactant is going to be our limiting factor, or our limiting reagent is what we often call that. And so once again, start with what you're given. Start with what you're given in both cases. Convert those grams to moles. So you would use your molar mass. And now your grams would cancel out or diagonally drop. So we'd have moles of magnesium. And now I can look at my equation. Now that I've got moles of magnesium, the equations are written in terms of moles. So I can see from my equation that 3 moles of magnesium equals only 1 mole of the product. So I can also write that as a fraction or conversion style ratio. And then go straight across the top and multiply. 75 times 1 times 1 divided by 24.31 times 3. And I see that I'm going to be able to make 1.03 moles of my product. Whereas my nitrogen, once again, my formula mass, I'd have to double the mass of nitrogen because I have N2. And we've got a 1-to-1 ratio. So if I go straight across the top, 45 times 1 times 1 divided by 28, I see that I'm going to be able to make 1.61 moles of the product. And I stopped before going to grams of the product because I just wanted to find out which factor is going to limit my ability to make magnesium nitride. And obviously that's going to be the magnesium. I'm only going to be able to make 1 mole of the product with that amount of magnesium, and 1.61 moles of the product with 45 grams of nitrogen. So my limiting factor, once again, magnesium. And so that is the most that I would be able to make. And so we'll be able to say now that nitrogen we have in excess. So what would my theoretical yield be? Well, my theoretical yield would be 1.03 moles. But of course, people don't want us to report chemicals in moles. So how do we convert from moles to grams? The molar mass. So I would calculate my molar mass of magnesium nitride at 100.94 grams. Multiply straight across the top. Notice my moles cancel out or diagonally drop, and I've got grams. And so again, my theoretical yield with that 1.03 moles is 104 grams. So if I actually ran this reaction and I only got 88 grams of magnesium nitride, what is my percent yield? Always the part divided by the total times 100. So 88 grams, my actual yield, divided by the theoretical 104 times 100. So I've got an 85% yield. So if you can do all of these stoichiometry type problems, going from atoms to moles, moles to grams, and back and forth, and using your balanced equation to convert from moles of one chemical to moles of another chemical, you should be in great shape.